A two-sample t-test, otherwise known as an independent samples t-test, compares the mean of a scale variable between two groups in your sample. The assumptions of a two-sample t-test are that the sample was recruited randomly, that the variable in the test is scale level of measurement, that the comparison variable, your categorical variable, has just two categories, that the values of both variables are independent, so if you're in one category, you can't be in the other, and that there is a large sample, so 30 or more participants, or the scale variable of test is normally distributed. Our research question is birth weight significantly different for mothers who smoked during pregnancy versus those who did not? So we have birth weight, a scale variable, and we want to know if it's different between two different categories of people in our data set. And that data set is weights, so you can get it into your class DAT folder either by uploading it or copying it from the course folder. Then, of course, we need to run our libname statement. And then we can actually conduct the two-sample t-test. And that code is proc t-test, data equals, class dat, that's the folder our data is in, dot weights, that's the name of our data set, sides 2, so our sides are 2 because we have a non-directional alternative hypothesis. The alpha that we set is 0.05. Our null hypothesis is that there is zero difference between the two groups, specifically no difference in mean birth weight between mothers who smoked and those who didn't. Then we specify our categorical variable, so class is a category, or class means categorical variable in SAS, so we say class smoke, and then var, this is our test variable, our scale level variable, birth weight. Run and highlight it and run. So you can see that we have descriptive statistics here for the mean birth weight in both the non-smoking and smoking categories. And before we interpret the results of the test, we need to figure out which p-value to interpret. Do we want to interpret pooled or not? So we come down here to this very last table and we look at this p-value. This is for equality of variances. If this p-value is not significant, and this one is not, then we can interpret the pooled p-value assuming equal variances. So in this case, we'll interpret the 0.0092, which is significant. If the equality of variances p-value was significant, if it was below our alpha of 0.05, then we would need to interpret the unequal variances p-value, which is 0.0075. In this case, it doesn't make that much difference, but them's the rules. The significant p-value means that there is a significant difference between groups. We can reject the null hypothesis and conclude that there is a significant difference in birth weight between babies born to smoking versus non-smoking mothers.